You may be wondering why I'm doing the recent history, and the reason is that I suggested when we first met to plan this workshop that I would be glad to do that, and they took me up on it, and I'm grateful for that. But the reason that I offered to do it was because my own involvement with sewage and septics around Chautauqua Lake began in 1960. That was the year I graduated from Jamestown Community College, and we did not have a county health department then. Public health in Chautauqua County was managed by the New York State Health Department. They had an office at the Hotel Jamestown, and every summer they hired what they called a camp sanitary aide. And that person went around the county and inspected various temporary residences, which included kids camps, farm labor camps, hotels, motels, and that type of thing. And we would look at sewage and water. In the case of hotels and motels, we'd look at the kitchen and things of that type. So I did that for 3 summers, and that sort of got my feet wet, so to speak. One thing I learned was that you never lean over an open septic tank with pencils in your chest pocket.
Or cell phones.
Or, yeah, well, we didn't have cell phones in those days, but that would be even worse. First, a look at public sewers where we are today, and you can see the key down here. We'll start with Chautauqua Lake, which you all recognize, I-86 here. And then we have, working our way up, there are some private small sewer districts on the lake. These are, for the most part, condominium units. And then the Chautauqua Utility District here, Chautauqua Institution. The North Chautauqua Lake Sewer District here at the Mayville end. And you'll notice there's also a little section here just south of Chautauqua Institution that is actually managed by the North Chautauqua Lake Sewer District, but the wastewater there is treated at the institution, which has their own district. And then finally, the Center Chautauqua Lake Sewer District and the South Chautauqua Lake Sewer District, and those are combined into the South and Center districts because they have a common wastewater treatment plant at Celeron. A little bit of basic information about the lake districts. The North Chautauqua Lake Sewer District, the wastewater treatment plant was completed in 1979 and underwent an upgrade in 2010. Has about 1,300 users, 11 pump stations. South and Center plant was completed in 1980. It serves some old areas. It serves the village of Celeron, the village of Lakewood, and the actual sewage lines for those villages go back to about 1940. So there's some older piping in the ground in those 2 villages. And you can read for yourself the number of users. The districts are interesting because they have 3 different types of conveyance lines. They have the standard gravity lines for some of the dwellings. They have grinder pumps for some of the dwellings, and they have vacuum sewers for still more of the dwellings. So it's a very, very interesting and somewhat technologically complex system. The Chautauqua Utility District was actually established at the institution in 1934, and it became independent in the sense of it has its own board, separate from the institution board, in 1979. And then a small one, Chautauqua Heights Sewer District, was actually established in 1973 and serves condominiums, villas, and so on in the Point Chautauqua area. It has been operated by the town of Chautauqua since 2004. Now, if we went back to the map, which I'll try to do, You can see there are some areas that do not have public sewers. This long stretch here and also over here. And what that means is there are there's an estimated 1,000 or so lakeshore dwellings with individual septic systems around the lake. So how did we get to have public sewers around the lake? There are really a couple of answers to that, and both of them involve house-to-house sewer surveys. The first one was done in 1964. This was done by the County Department of Planning in cooperation with the then New York State Health Department office here in Jamestown. 2 individuals were hired. I was one of them, to go house to house around the north end of the lake in what is now the North Chautauqua Lake Sewer District. We had preliminary information. We had information from the tax maps. We got a diagram of the property, and we had the name of the property owner. And we went house to house and did these things. We sketched the house on the map. We sketched the location of the well, the septic system. We put dye in the toilet to see if it went into the lake or into a nearby stream or ditch or something like that. And then we went on to the next house. So we did that all summer and wrote up a report on that, and they were presented to the Planning Department and the New York State Department of Health. Now, some things have changed on the shoreline since 1964. One thing is that Camp Chautauqua, you all know Camp Chautauqua, not far up the lake from here, a campground, large campground. In 1964, that was a youth camp. Actually, it was 2 youth camps. There was Camp Chautauqua and also Camp Timbertop. And Chautauqua was for Chautauqua was for girls and Timbertop was for boys. And it was an ideal situation because they were right next to each other. And usually the staff were young college kids, and it was probably even more ideal for the college kids. But that's a scene of Camp Chautauqua. Before that, it was called Sylvan Park, and it was a park that was owned by the Broadhead family, who operated the trolley lines around the lake and the steamships, and also began Celeron Park. So it's got a bit of a history, and now, again, Camp Chautauqua is there. There were some other changes. There were more youth camps around the lake than there are now. There are still some, Camp Mers, Camp Aniasa, Camp Mission Meadows, the Lutheran camp, but there were more in the early and mid-60s. We didn't have condominiums in those days. The commercial cottages were here, but they were smaller. They were largely fishing camps and by today's standard, somewhat primitive. And we didn't have as many larger homes around the lake as we have now. Some things have not changed, though. And one of the problems that we'll be talking about again is small lots. This is a map of North Harmony along the lake. I obtained from Sally Carlson, the town supervisor. And I just want to point out the size of the lots, long and thin. We'll get back to that topic. Now, back to the surveys. The second survey was done in 1982. And by that time, we had a county health department, which was formed in 1965. So the county health department conducted that survey. It covered the center Chautauqua Lake Sewer District here, plus the east side of the South District down in here. I had a contract with the health department, and I hired 4 students. We started with 3, but ended up hiring a 4th to do a lot of the house-to-house work. We used the same methods as we used in 1964. including putting dye in the toilets and flushing it down and waiting to see if it came out into the lake or a ditch, that kind of a thing. And that survey received a lot of publicity. Some of the publicity was before it actually began. The health department was going to test sewers. They let people know that. How we did it was also in the paper. So some before publicity. There was also some after publicity, and those headlines really gathered attention. For example, people drinking own sewage. That got their attention, and I'll explain why in a minute. 66 wells in the area were found to be contaminated. And then this served to augment efforts to develop further the South and Center Chautauqua Lake Sewer District. The idea of a regional sewer system. The County Board of Health got involved, urging completion of the sewers. There were editorials in the Post-Journal. And then the idea, again, getting back to contaminated wells. So there was a lot of publicity about this. And one of the reasons, again, you've just seen this, but one of the reasons was small lot sizes. The essence of it is that on a small lot, it's difficult, if not impossible, to have your well the appropriate distance from your sewage system. And you'll hear more about that later, but the basic minimum is 100 feet, and you can't do it. And even if you can do it for your well and your sewage system, you need to consider your neighbors. Where is your neighbor's well relative to your sewage system? Where is your well relative to their sewage system? So at the end of the summer, we developed a final report, and I know you can't read this, but we focused on these things: the type and adequacy of the individual dwelling sewage system. We learned that by going house to house. The source and purity of the water supplies. We took water samples, we sent them into Albany, we had them analyzed for bacteria. The groundwater purity. We didn't do this at every lot, but we dug holes, we took groundwater samples, and we sent those into Albany to be tested for bacteria, primarily coliform. And finally, ditch and pipe drainage. So those four things were what we looked at and what we reported. And here in this one, you can see this is the area. For example, Bellevue Road. We had the four columns, how many sewage violations in that area, how many contaminated water wells, how many contaminated groundwater areas did we have, and how many contaminated sewers or pipes. That is to say, how many pipes or ditches were people discharging into. So the statistics. The sewer violations ranged from 0 to 41%, depending on the area covered. Well contaminations to 100%. We'd only had about 48% contact success. In other words, we'd actually never got to interview 52% of the people. 44.6% of the sampled wells were contaminated. 13% had sewage violations. All ditches and pipes that we sampled were contaminated. And all groundwater samples were contaminated. So these are the kind of statistics that produced the newspaper concern, the Board of Health concern, the editorials, and so on. And the questions we asked then were very simple. Do we accept these conditions, or do we try to change them? And the question now, what conditions still exist in the unsewered areas of the lake shore? And the answer to that, of course, is We really don't know. So we're looking at the ecological health of Chautauqua Lake. We're looking at the public health, the water wells, the ditches, the streams in the lake watershed, and both of these have an impact on the economic health of the county. So it's a very, very important question. What are the conditions that are in the remaining unsewered areas, public sewers, around Chautauqua Lake?
So what I'm going to do tonight, I'm going to talk about residential septic systems. We've got a lot of material to cover. I'll try to take some questions along the way if we can, if you have them. I'm also going to talk about what are called advanced or enhanced treatment units, which are proven technologies that are used in small lots, difficult sites, along the lake. Obviously something that your county health department is starting to take a look at for future consideration. So I'm going to give a brief history of residential septic system types, and I'm laughing because some of the things, Tom, that you pointed out in your surveys and history, and thanks for doing that. I'm going to show that that's really the way things used to be done. I'll talk about residential septic system components, talk a little bit about the treatment process. I'll talk about enhanced treatment units, which are known as ETUs, advanced treatment units, or alternative treatment units, ATUs, sometimes known also as aerobic treatment units, ATUs. So it's kind of all the same terminology. I'll talk about early warning signs if you're going to have septic system problems, how to maintain your septic system, talk about how residential septic systems are typically inspected. It's different, in different counties, different municipalities, and then try to have a little bit of time for questions and answers. Let's see. Okay, evolution of conventional septic systems. As Tom just pointed out in his survey, out of sight, out of mind was always a great idea with septic systems in the old days. You could have your waste going out of the house into a barrel, into a 55-gallon drum, into a metal tank, that no doubt would start rusting within 2 or 3 years. As I also saw in some of his survey information, straight pipe to the lake, stream, or ditch, which, interestingly, I noted in your data, Tom, every one of those failed, which certainly would make very good sense, because that's just basically sending raw, untreated sewage into the environment. Cesspools, which I'll talk about in a slide here in a minute. Everybody's heard, I assume, about dry well or seepage pit. There's a difference between a cesspool and a dry well or a seepage pit. With a cesspool, everything that comes out of the waste pipe out of your house goes right into a cesspool, which I'll show you a picture of in a minute. All the solids, all the liquids, everything. There's no separation. With a seepage pit, the slight advantage is at least there's a septic tank in front of that seepage pit to collect some of the solids. Then I'll talk about concrete or plastic septic tanks, single compartment, 2 compartment. Then I'll talk about septic tanks with effluent filters, easy access and safety risers, and then dispersal fields. And when I talk about dispersal field, everybody's got a different term. Leach field, drain field, dispersal field. They're all the same thing. It's the part of your lawn or your property where that effluent eventually goes out through a pipe and stone system or gravellous chambers, although I don't think you guys, do you guys do gravellous chambers here yet, Paul? Not yet, okay. Sorry?
Very little.
Very little, okay, all right. And then, I'll mention New York State Department of Health starts the regulatory process for septic systems. Their 75A regulations are what cover residential new construction for septic systems. And then I'll talk about enhanced treatment units, which is what this has really evolved into. Okay. This is just a basic cesspool. You see the access manhole on the top, and you see these slots. So what happens with a cesspool, the waste comes out of your house, it goes right into the cesspool, and it just starts leaching out the sides. So there's no chance for all the solids or much of the solids to settle. There's little, if any, chance for treatment there, other than the bottom of that cesspool is open, and eventually it's going to work its way into the ground and the groundwater. This is a picture of a 1,000-gallon concrete septic tank. These are access risers up here. This is either the inlet or the outlet pipe hole. There's one on each side. But a 1,000-gallon concrete septic tank, what's different about that from the cesspool? You'll notice that's watertight. Nothing's going to get out of there that doesn't go out of that pipe. This is, and I apologize if the schematic is not easy to see, but it's pretty specific. So conventional or traditional residential septic systems that we all might be used to. House, outlet, wastewater pipe outlet, septic tank. These are the solids settling on the bottom of that septic tank, and then there's a pipe from the outlet of the septic tank going to the seepage pit, which looks an awful lot like that cesspool before, and then it goes into the ground. The advantage, again, to this over just a plain cesspool is at least we're collecting the solids here in the septic tank before they go into the ground. Up here, you have another traditional schematic. So you got the wastewater outlet pipe to a concrete septic tank. This is a distribution box, which I'll show you a picture of one of those in a minute. And this distribution box spreads out this septic tank effluent, which is primarily liquid, into all your different drain fields. This area here is typically a requirement for what's called an expansion field. So if your drain field number 1 fails, a lot of times you're required to have an expansion or replacement field that's readily available, readily identified so that you can move over to that. Inside a septic tank, which is really what this is. So the house is over here. This is a 4-inch wastewater pipe coming from the house, comes through a baffle or a sanitary tee. It goes out over here to the distribution box and to eventually to the drain field. In the middle is what's interesting. This is a riser. So a lot of times you'll see these mounded green plastic tops. That's typically a riser for a septic tank where they're screwed on tight. Shouldn't be an issue with safety because you got to really, sit down with a screwdriver and open those things up. But it provides easy access into the tank for the pumper and for some other things that you'll hear me talk about. What happens in a septic tank, all the sewage is coming in, the waste is coming in. The heavy stuff floats to the bottom as sludge. The liquid in the middle is the septic tank effluent that's eventually going to work its way out to the drain field. The scum up here is what are called floatables and fats, oils, and greases. So what ends up here is anything that's heavier than the effluent. It's not heavy enough to sink to the bottom. Things that can end up here, as I mentioned, fats, oils, greases. Other things that you shouldn't be putting in your septic tank will end up here too. Paper towels, any kind of plastics or rubbers or anything like that. And we'll talk do's and don'ts here near the end of this, but that's what will end up here. And what will happen, I'll show you a very good idea. The effluent is going to work its way up here and out, okay? It doesn't go across, because if it went just across, all that scum would start migrating into your drain field, which you definitely don't want. So the baffle or the sanitary tee goes down enough to where it's just going to allow the liquid to go up and to go out that pipe. This is a picture of an effluent filter, and I'm going to go back and forth here a little bit. The effluent filter goes on this outlet pipe. It's, I want to say fairly new. I would say in the last 10 or 15 years, effluent filters have become very popular. They're inexpensive, but they require maintenance, okay? So the idea with an effluent filter, it goes on the outlet, and it's catching, and I'll go back. This is an effluent filter in the tank. That liquid effluent, septic tank effluent that's in the middle, it's got little particles in there. You want to prevent as many solids from getting out to your septic tank drain field as humanly possible. And one of the best ways to do it is with an effluent filter, okay? Now, with that filter, that's another reason why you want to have a riser for easy access into your septic tank. I think Tom said you never lean over a septic tank with pencils or never lean over a septic tank with anything because that thing is full of methane gas as well, even though you've got a vent taking care of most of that. If you ever open up a septic tank, step back, let the air flow out and never stick your head inside that. This effluent filter is located, you can just pull it straight out. We install them on the sanitary tee. You pull it straight out, it's located maybe a 12-inch grab down, a 16, 18-inch grab down. You pull it up, you rinse it out, you stick it back in, you do that once or twice a year. That's a terrific way to extend the life of your drain field. And again, they're not expensive at all, but they require that you pay attention, require maintenance. If you don't, a clogged filter could cause backup into your house. Your drain field could be fine, but because nothing's getting out of that clogged effluent filter, if you're not cleaning it, you could create a problem, which, again, it's not a complicated process at all. You've just got to remember to do it once or twice a year, depending on the manufacturer's specs. And again, you take it out every 6 to 12 months. So effluent filters, which is really right here on the outlet baffle of the sanitary to your septic tank, is a great way to extend the life of your drain field and keep solids out. You want to keep solids out of your drain field, your dispersal field, if at all humanly possible. This is a picture of a distribution box. So out of that septic tank, a 4-inch pipe runs, and it runs to the distribution box. In the distribution box, we usually have speed levelers. And what speed levelers do is they set each of these holes, and each of these holes is going to represent a line in your drain field, which I'll show you in a minute. So it takes all that septic tank effluent, that liquid that's coming out of the tank, and it spreads it out so it goes evenly down however number of drain field lines you have. If you have 8, it'll spread it out over 8. If you have 6, it'll spread it out over 6. If you have 4, it'll spread it out over 4. One of the most misunderstood and forgotten about components in a residential septic system is the D-box. So here's a pretty good sized house under construction, 1,000-gallon septic tank, outlet. Here's your distribution box that I just showed you. So all of the drain field lines are running out of that distribution box, and it spreads it out over the whole field. Now, this is a typical leach field makeup. You've got perforated pipe, which is pipe with holes in it, and it goes down into stone, and that's how the effluent out of your house, out of your septic tank, works its way into what we hope is good soil. So a typical stone and pipe system is what's out in your drain field, and that's usually a 4-inch perforated pipe with gravel and stone underneath it, and then down into the soils. What are becoming more and more popular are what are called gravelless chambers or infiltrators. You notice it almost looks like an upside-down turtle. So they take the place of the pipe and stone, and you just line them up in rows. They have a lot more capacity. They allow for a more even distribution of that effluent across your whole drain field, and they're fairly inexpensive. Okay, one of the things that we always want to remember is eventually we got groundwater. You don't want to have a situation where, okay, this is just to show, the well is always a long ways, preferably away from the house. Setback is usually, I think it's 100 feet from the drain field, or the distribution box is probably right. So well here, house here. Here's your wastewater pipe coming out of the house to a septic tank, to a distribution box, to the drain field, which is all those lateral lines. What happens, good soil does a great job of treating wastewater. You want to keep as many solids out of it as possible because you don't want to clog that soil up. But the soil will absorb the wastewater. It'll go through a purification process. Eventually, it'll get down to the groundwater, and then it'll move away. What you don't want is you don't want everything sitting here. Okay, now I'm just going to talk a little more technical about primary and secondary wastewater. Typical residential raw sewage comes out to be about 300 parts per million of something called biological oxygen demand. BOD is just a way people in the wastewater industry look at the amount of waste, the waste strength that's in effluent. And I'll talk more about that later, but it's a common way we measure things. In the septic tank, we always say septic tanks provide primary treatment. What that means is they capture, and most of the solids settle down into the bottom of that septic tank. Again, the key to a healthy septic system, keep the solids out of your drain field. So a septic tank provides primary treatment, and it reduces that raw sewage. It cleans that raw sewage to about a 50% level, down to 150 parts per million from 300. Secondary treatment is something that people used to think could only be done in a central treatment plant or a central sewer plant. Central treatment cleans it to about a 90% level, okay? Secondary treatment must get to at least 90%. Enhanced treatment units and alternative treatment units provide secondary treatment levels for residential wastewater, ETUs and ATUs. They can do that, okay? New York State Department of Health, their 75A regulations, allows for enhanced treatment units, alternative treatment units, secondary units with a number of conditions. Number one, the state can say something, but if the county doesn't want to have it, that's fine, that's up to the county. And if the municipality wants to make it even tougher, that's okay too, the municipality can do that. So just because the state says something, that doesn't necessarily mean that's what's going to be the best thing for your area. So state provides a level of regulation, county can be stricter, it can't be less strict, it can be stricter, municipal can be stricter, can't be less strict, okay? So New York State 75A is for new construction, and they allow enhanced treatment units, alternative treatment units, but with a number of conditions. Number one, must be a PE or professional engineer stamped design plan, okay? Number two, there must be what's called a responsible management entity somewhere within that municipality or that area, okay? There must be a signed maintenance agreement with the manufacturer for that enhanced treatment unit or alternative treatment unit, and that maintenance agreement must be followed. Enhanced treatment units typically require an inspection or maintenance twice a year. NSF 40 certification is also required. Think of Underwriter's Laboratory, as a way that we were always told growing up, this product's safe, it's got an Underwriter's Laboratory stamp of approval. National Sanitation Foundation, NSF, is the Underwriter Laboratory's stamp of approval for all things water and wastewater. NSF 40, which is a general class certification for enhanced treatment units, secondary treatment units, is required in New York State. So I'm going to show you some pictures of some of these coming up. Anything I show you is an NSF 40 system. As part of an engineering firm, we wouldn't look at anything that's not NSF 40 certified. NSF 245 certification is for enhanced treatment units that are nitrogen reducing, that have a nitrogen reducing certification that is 50% reduction or greater. So one of the systems I'll show you has that as well. Tertiary systems are available for both nitrogen and phosphorus reduction. By tertiary, what we mean is this. We always look at it as a treatment train in wastewater. You have a septic tank providing your primary treatment. If you have an enhanced treatment unit, that's providing secondary treatment. Remember, the primary tank can take it to about 50%. The secondary can take it to about 90%. Tertiary, in many instances, can take you up into anywhere from 95 to 99%, depending on what we're looking at. For nitrogen and phosphorus, nitrogen is most typically a very big problem wherever there is salt water. Phosphorus is a big problem wherever there's fresh water. Obviously, for you guys here, you're a lot more worried about phosphorus reduction. And as I was explaining to some of the gentlemen who are going to talk in a little while from the county, there are a number of exciting new things happening in the tertiary treatment arena for phosphorus reduction for residential. Okay, the pictures I'm going to show you, with the exception maybe of one, are of Skaneateles Lake. Skaneateles Lake is an unfiltered water supply for the city of Syracuse. In 2001, the US EPA and the city of Syracuse funded a study at Skaneateles Lake, and it was the first time these enhanced treatment unit technologies were studied, looked at, installed, tested, and monitored in New York State, okay? This is Skaneateles Lake, again, unfiltered water supply, city of Syracuse. This house obviously is right on the lake. This is the entire enhanced treatment unit system for this house. Septic tank, pump tank, peat filter. This is where the effluent's going, is right in this area. Because it's clean to such a level, in the environment up there, the county and the state allowed that because this house is built. It's there. It had a failing system. What are we going to do? What's the best solution? Put in another old-style conventional system? Not really going to help. So what they started to do up there is put these enhanced treatment units in. This is another one, which you'll see two pictures of this. The lake is towards me. This is the house here. This is the whole enhanced treatment unit system for this gentleman's house, and it's providing 90% plus treatment. Septic tank, pump tank. This is the secondary treatment unit, which I'll show you the inside of in a minute. It's got what's called a textile sheets, and this is the whole leach field or dispersal field or drain field. It's a bottomless sand filter. It's 20 feet long by about 8 feet wide. This is the whole system for this house. This is another picture of it, just to give you an idea. It's a small footprint. Inside, this is the secondary treatment unit. This happens to be an Orenco Advantex. Inside this box are all these hanging textile sheets. What you want with wastewater is you want to give the bacteria a place to reside while the healthy bacteria is eating up the bad bacteria. You have both in a septic tank effluent. So you want media, these are textile filter medias, you want media that provide a large amount of surface space for these bacteria to latch onto. This is a very interesting system. This whole system would fit on the back of a pickup truck. I have a couple of brochures up there that show that. This is an NSF 40 certified system that is everything in one. It does not require, for its NSF certification, the septic tank in front of it. This part here is the septic tank. This is the secondary treatment unit part. This is the recirculation and water storage part. This unit is about 7 feet high by 5.5 feet by 3.5 feet wide. These are, remember the textile sheets I just showed you? There's a lot of different technologies in the enhanced treatment units, the advanced treatment units, to treat wastewater. Those textile sheets were great. They had a lot of surface area for the bacteria to reside on while it's getting eaten up. This is the treatment media here. These are plastic balls. And if you can see, they're about the size, they fit in the palm of my hand. The bacteria all attaches to that. There's even smaller versions of these balls in here. So what happens here is the wastewater comes in with or without a septic tank in here. Any solids settle here. The secondary treatment happens here. 30% of it recirculates back, goes through the whole process again, which gets you to an even higher treatment level performance. And this is, can you see how clean that effluent looks? That's out of a septic tank. That's when you talk about 90% plus treated effluent, septic tank effluent, that's what it looks like. It looks nearly clean. All of that in just this one unit. That's a Clarus Fusion. This system was actually invented in Japan. Zoller Pump Company, which is a pretty common pump company, some of you folks may have heard of them. Zoller Pump Company bought the rights to this unit. There's 9 million of these installed in Japan, all with surface discharge. And it's a lot harder to get approval for surface discharge than it is subsurface. 9 million of these providing wastewater treatment in Japan. This is a Septitech system. Septitech is an NSF 245 certified system, which means it reduces nitrogen by at least 50%. So what happens here is a few interesting things. And actually, I'll show you one other thing. Going back to this unit, this requires a blower to put air in. A compressor brings air into it because you need air to eat up that bacteria. The reason I say that, that's what you've got here too. You've got a compressor putting air into this system. So in a Septitech system, everything's different. There's all kinds of different treatment media and technologies you can use to treat wastewater. Wait till you see, remember we had textile sheets, then we had those plastic balls. Wait till you see what this thing uses. This is the septic tank, wastewater coming from the house. This is a control panel because this has a pump. And with a pump, you need a control panel so that if, God forbid, if the pump starts, you got an alarm that can go off, and you can deal with the electrical, or your operations and maintenance folks can. Septic tank goes into the treatment unit, and it has a very good recirculation process. This is the media in here that the bacteria clings to and gets treated. And this is just a dime, 10 cents. These are polystyrene beads. These are pillows or bags full of these polystyrene beads. That's what's in here, where that bacteria clings to those, while the healthy bacteria just continues to eat it up and eat it up and clean it up. Polystyrene beads, textile sheets, plastic media. What have we got left? I'll show you one more. Peat moss. This is what's called a very fibrous peat that comes from Ireland. First time I heard that, I said, boy, that's not very environmentally friendly. But here's the good news. In Ireland, they cut that peat up and throw it in the fireplace. Here, at least, we're using it to clean water. This peat comes in these tubs. Each tub can treat 150 gallons of wastewater. Figure 1 tub per bedroom in a house, 3-bedroom house, 3 tubs. What happens is the septic tank captures the solids, the effluent comes into the top of this manifold and gets sprayed over. You see these lines here? Those are pipes right underneath it that look like this. That effluent gets sprayed in there. It works its way over a 48-hour period down to the bottom of that tub through this peat, and it is so clean by it gets to the bottom of that. It's absolutely amazing. There's two ways to disperse it from those tubs. This is, again, here's Skinny Atlas Lake over here. There's no frontage property to put a septic system for this house, so they put these 3 PureFlow Irish peat modules here. The one thing I don't like about them is 8 inches of that module has to stay above ground because they've got air weep holes here on the side, so 8 inches above the ground. But that's the bad news. The good news, very easy to get to, very easy to take care of, but you can do some landscaping around it. But those 3 modules treat this 3-bedroom house, and they disperse it into this very undersized drain field, because that's all the drain field the gentleman had. Okay, now I'm going to talk about early warning signs for septic system problems. You know, you're going to laugh because you sure don't need me to tell you an awful lot of these. If you got gurgling sounds from the toilet, you may have a problem. If you got slow draining sinks, tubs, or showers, you may have a problem. Of course, if you got wastewater backing up into the household, drain, or basement, you know you have a problem, and that's not what you want to have. If you smell a strong foul odor around your septic tank, your distribution box, your dispersal field, you may have a problem. If you have surface ponding around them, and what that really means is you're starting to see water above ground, or you're feeling really soggy ground. If you have that around your septic tank, your distribution box, or your drain field, you probably have a problem. If you see those long green, dark green, lush strips going down your drain field, you can see them. You know, there's 5 of them if you got 5 leach field lines. You might think, hey, everything's working great. It's not working great. What's happening is that effluent, the liquid, is not going anywhere. Remember that schematic I showed you where it should work its way gradually into the groundwater as it's cleaned? Well, if you see those long, lush green lines, especially in the summertime when it gets drier, that means that effluent's not going anywhere. And it's making your drain field look nice, but it's not going anywhere. Last thing, which obviously is important to you guys here, aquatic vegetation growth in a waterfront property. If you see a lot of algae right out, you know, you walk into the lake from your house and you see a lot of algae there, chances are there's a septic system or something polluting that particular area. Those are early warning signs. This is just an example. You know, we talk about ponding or sewage breakout. This is the kind of stuff that you'll start to see right here. EPA came up with a website, a new website called Septic Smart. If you just Google EPA and Septic Smart, it'll take you right to it. Here's what they say about what you should do to take care of your septic tank. There's 4 major factors that influence how frequently you should pump your septic tank. How big is your household? What kind of wastewater volume are you generating? Are there a lot of solids in that wastewater? And again, solids in wastewater is something that always leads to problems if you have excess solids. And what's your septic tank size? New York State regulation, 3-bedroom house, 1,000-gallon septic tank. 4-bedroom house, 1,250-gallon septic tank. 5-bedroom house, 1,500 gallons. Just keep adding 250 gallons per bedroom. So you want to have the right size septic tank. When you call a septic service provider, pumper, a more common name, when they come to pump out, they should at least do a visual look at your septic tank, right? Are there any leaks around the tank? Before they start to pump, when they stick that hose down there, what does the scum and the sludge layer look like? And here's some rules of thumb from the EPA. If the bottom of the scum layer, and remember the scum layer is it's lighter than the effluent, the liquid, so it floats up. Sludge goes to the bottom, scum layer goes up. Fats, oils, greases, floatables, things that shouldn't really be, the floatables tend to be things that you shouldn't put in the septic tank. But if the scum layer is within 6 inches of the bottom of the tank outlet, and those are those two baffles or sanitary tees in and out, if it's within 6 inches of the bottom of that, you should pump your tank right away. Or if the top of the sludge layer is within 12 inches of the tank outlet, so in other words, your sludge is building up from the bottom, your tank needs to be pumped. That's per EPA Septic Smart. Preventive maintenance for your septic, and I'm glad you have a handout because I know it's kind of hard to read, but a brief visual inspection of your septic system is always a good idea. You're looking for any signs of leaking, strong odors, surface ponding around the tank, the D-box, the drain field. Here's something you should never do, and believe me, people do it. Never drive or park a car over any part of your septic system. Your septic tank, your distribution box, or your drain field. It'll compact the soil, it may damage the tank, it may crush the distribution box, it may damage or crush the pipes or the gravellous chambers in your dispersal field. Never do that. Don't put the following down your household drain. And it's a long list, I'm not going to read it all, but hair, coffee grounds, dental floss. I'll read the ones that always amaze me that people do. You see people pouring, they paint the house or paint a room and then they pour their paint down the drain. Never do that. I mean, a septic system is not designed to handle that. It's not really designed to handle any of the stuff on this list. Paper towels, fats, oils, greases, those are the things that will end up in that floatables. Cigarette butts will end up in that floatable scum section. Don't strain your drain. If you got a household leak and you know it, fix it. Dishwasher and clothes washer, only run them on full loads. Don't run them, when you got just a little bit of laundry or dishes. Spread washing clothes out over a whole week. I know some people, they get home on a Saturday, they do 5, 6, 7 loads of laundry. That's not good for your septic system. You want to spread out your laundry across the week. Do 2 or 3 in a day. Check and clean your effluent filter. Remember that if you're going to put one on, you got to make sure that you're checking that every 6 to 12 months. Make sure your risers are secured. Here's the other thing. Keep a record of your septic system. There's, terms like as-built or schematic. A lot of people, they buy a house, they don't know where their septic system is because the person selling the house doesn't know where it is, which is not a good sign because that means, do you think they had it pumped? If they don't know where it is? I don't think so. And a septic system should be pumped every 3 to 5 years. But when you're going through maintenance, you want to make sure that you have a schematic, you know where your components are. Inspect for surface infiltration. Roof drains should not go to a septic area, whether it's your tank, your D-box, or your drain field. Look for any infiltration flows from swales. You don't want to see any surface or groundwater going towards your septic leach field or drain field. Sump pump discharges should not be into your septic system. Watch out when you have stormwater runoff from major weather or flooding events. Go take a look at your system visually to look like you escaped the damage. Remember that concrete septic tank, it's watertight. They're tested to be watertight when they go in. So you should be okay, but you take a look. Groundwater intrusion. Make sure there's no house footer drains with anything hidden going into your drain field. If you've got high ground, if you see, you're walking and you're not walking in water, but it doesn't feel spongy, but there's some, you got high groundwater, you may have something underground that's leaking. You want to pay attention to that. Household plumbing. If you don't know where your septic system is, go down in the basement, find your wastewater outlet pipe, whatever direction and whatever wall of your house it's going, start looking in that direction for your septic system because, Usually they're going to be a straight run out. We very much frown on 90-degree turns on those kind of pipes. So if you don't know, and nobody seems to know, get on the basement, find the outlet wastewater pipe, and see which direction it's going. Your septic system's going to be in that direction. Locate any other plumbing exits. Check and look around for leaks like we've talked about already. Are there any toilets, washing machines, anything in the basement? Sometimes those things are easily forgotten. High impact connections. Not a big fan of garbage disposals for septic tanks because you don't want to have solids going into a septic tank system. But you know, if you have a garbage disposal, you really should have your septic tank pumped more frequently. Hot tubs. Hot tubs should not disperse into your septic system. Grinder pumps. My partner Eric hates grinder pumps. He always says, let's capture all the solids right at the house and only pump effluent. But grinder pumps are something that if you have them, it's grinding up all that waste and sending it out. So something to pay attention to. Inspections. I'm just about done here. Confirm all the components, and we've talked about them. Septic tank, distribution box, dispersal field. Determine condition and functionality of each. Visually, you can determine that. Otherwise, you know, if you want to open up a septic tank, you should really have somebody, you know, who knows how to do that, your pumper. They'll look at the baffles, they'll look at the sanitary tees, they'll make sure there doesn't look like any crumbling of the tank itself if it's concrete. Check the effluent filter, take it out, rinse it, put it back in, make sure the risers are secure. Locate and inspect distribution or drop boxes. I've only talked tonight about distribution boxes. There's also something called a drop box, which just drops down in steps. Instead of having a flat level drain field, you have it in steps. One of the most easily forgotten components of a septic system is a D-box. I can't tell you how many times I've seen failing septic systems because the distribution box got crushed or plugged up or the pipes came loose, and everybody said, well, it's got to be the tank or the drain field. D-box can be a problem too, and it can be a fairly easy fix. Locate and inspect your dispersal field. Make sure you know where it's at. Document the results of the inspection and make sure you have a schematic of your system. You know where your wastewater pipe's going out. Make sure you know where your septic tank is. You know where your D-box is. You know where your drain field is. You make note if you have an effluent filter on your septic tank. You put that on your calendar. If you have your risers. If you have an enhanced treatment unit or alternative treatment unit somewhere down the road, you must follow the manufacturer's maintenance requirements. Usually it's an inspection once or twice a year, typically twice a year. To get an NSF 40 certification, all manufacturers have to provide 2 years of warranty, which means there's no charge to you for the first 2 years. After that, there's a maintenance agreement and a charge. Typical average for a residential is $250 to $300 a year for a maintenance contract that I've seen for enhanced treatment units, and I've seen plenty of them.
This section of the program is good. We're going to describe what the Chautauqua County program is, or as far as sewage installation or private sewage, and additionally what we do on a property transfer. Mr. Boria made me this nice map here, and it's kind of similar to Mr. Erlinson's map, except it has the towns on it, and you can, as far as municipal sewerage, and you can see that the bulk of the North Harmony line and part of Chautauqua, and then up in Ellery, there's no public sewer. So those areas are regulated by the Chautauqua County Health Department. The public health law gives us authority to establish a local board of health, or Chautauqua County Board of Health. Also gives us the authority to or the Board of Health the authority to implement the sanitary code of the Chautauqua County Health District. And it's had several amendments over the years. The first version of this was created in 1965 when the health department was created. And incidentally, I understand the impetus for the health department's development or creation was the problem of unresolved sewage, or sewage, like Dr. Erlinson said, sewage in the ditch, sewage going to the lake, just those kinds of things was the reason that the health department became established in 1965. Here's kind of some things other things that environmental health does, particularly, most importantly, rabies. We investigate every mammal bite that gets reported to us in the county. We also look at water and sewage systems or septic systems on every property transfer. We also oversee or regulate drinking water in the county, public drinking water, swimming pools, bathing beaches. Bathing beaches in particular also kind of are related to the topic tonight because on Chautauqua Lake, obviously, there's several public bathing beaches, so they are impacted by the problems on the lake. Temporary residences, we alluded, Mr. Erlandson alluded to children's camps, and we have several on the lake, like he mentioned. Campgrounds, of course, you know that there's several of those as well, and mobile home parks. We also do investigate complaints that are called into the health department, so on and so forth. You can read the rest of that if you like. Particularly property transfers we like to talk about briefly, and I'm guessing the process hasn't evolved much as far as at least evaluating the sewage system on property transfers. It's the law that, or it's a sanitary code regulation that we evaluate a septic system anytime, or in most cases, when there's a change of ownership of properties. And similar to what was described earlier, it's just a matter of putting dye in the toilet and running water and going out and evaluating the areas of potential disposal field. Now, a lot of these houses we have record of, or we have a plan in place of where the septic is, and so we know where to look. Other areas there's no record of a septic system, so it's kind of a little bit of detective work involved. So we kind of, over the years of doing these, we get experienced and kind of know the prime areas where you would look, obviously downgrade, or, the ditch, or, the swale out back, or where have you. Private sewage, Mr. Schneider and Mr. Mentley will get into great detail on this, but again, the sanitary code of the Chautauqua Health District requires that people putting in septic system for individual residences get a permit through the health department. And again, we talked about nuisances a couple seconds ago, but that's how we record a lot of these violations. The neighbor will call in, they just, in the summertime, these sewage violations that are bubbling up in the ground, they get quite aromatic. If you're close proximity to your neighbor, at some point they may get mad and call in, and then we go out and dye test, and then if we do find a violation, the homeowner has 3 weeks to get a permit, and then another 3 weeks to correct the sewage violation. Based on the state's design manual, we have our own design criteria. It's a little bit different than the states, and as far as for example, on sand filter systems, the minimum tank size is 1,500 gallon tanks, where the state may call for a 1,000 gallon tank. Our sanitarians that go out and do work in the private sewage program work under the direction of Mr. Paul Schneider, our professional engineer on staff. They conduct site assessments. They work with contractors on a design that's most suitable for the parcel or the soil conditions. Contractors submit an application, we issue the permit, and then when the permit is installed, then we go out and do what they call a final inspection on the property. Effective January 1st, 2009, the sanitary code was revised, required on new construction, parcel size be a minimum of 40,000 square feet. Why the increase? Well, we talked earlier about separation distances between water wells and septic systems for obvious reasons. You don't want to be drinking filter sewage. So, if you think back to that slide from Mr. Erlinson in Stowe, where you have these 50-foot by 100-foot lots, it's very difficult to get those separation distances. So on new construction, we have to go in that direction so we can get the required offsets from the water well to the sewage disposal system. And also it allows for, in the event the system fails, it allows you to have area to put in the replacement system. Variances. Now we've probably had about 3 variances since the law went into effect on these 40,000 square foot new construction parcel requirements. And when a variance is for cases where, say, somebody bought a lot before the code changed, and it was, at that time it was, it was acceptable, it was at least 20,000 square foot, but now it's not, doesn't meet the minimum. They could petition the Board of Health with an engineering drawing on how they're going to protect, the water, groundwater, water wells of themselves and their neighbors. And the Board of Health has approved, I think, 3 of these since the law changed. Also, it's a requirement of the sanitary code if you're building onto your house, adding bedrooms, the health department evaluates your septic system, and if there's no record or it's inadequate, then you're required to get a permit and enhance your system. And to summarize, that a permit is required from the health department before engaging in a correction or getting a building permit for new construction, or when the house is expanded. And again, we're in the business of also protecting groundwater, so those are the chief reasons. Moving forward, we're looking at our program hasn't changed, and as far as property transfers in 48 years, we're looking down the road in that if, say for example, we went to your house and we put some dye in the toilet, we don't have a record, we don't document a violation, then that system passes. Those type of things may evolve into more enhanced inspections down the road, particularly on these areas that are in close proximity to the lake.
So tonight I'm just going to briefly go over actually designing a private septic system. There's been a pretty good introduction already to the process of the different types of septic systems, that include the older designs, and also the the enhanced treatment unit type of septic systems that are actually just starting to be evolved now. These are our 2 main design guides, the regulations that were put out by the State Health Department. On your left is Appendix 75A, and on the right is the design handbook for residential wastewater treatment systems. So in this presentation, I'm going to go over very quickly, actually running down through the main important sections of 75A pertaining to designing a private septic system. Sanitary sewage flows. Acceptable sanitary sewage flows has already been discussed tonight. They would include flows coming from your sinks, toilets, and bathtubs. The plumbing from each must be connected to your main drain line in your house and flow to your septic system. Unacceptable sewage flows that you do not want to be discharged to your septic system would include roof gutters, footer drains, sump pumps, and also water softeners. Water softeners discharge salt, and salt is not a good thing to discharge to your septic system. If you have a water softener, 75A states that it should discharge to a separate subsurface discharge system that's at least 250 feet away from a well or a water course. If you cannot obtain a 250 feet separation distance, you can connect it to your septic system, but it's preferred to have its own separate discharge. This might be a little blurry here, but this is a table that we use for designing the amount of water that the septic system needs to be designed for. And it's broken down into the age of the plumbing fixtures in a house. It's just been revised in 2009, 2010. Most of the newer fixtures since 1994 are lower flow style fixtures, and they've got a lower design flow of 110 gallons per day per bedroom. But as you can see, as you get down into the older fixtures, some of their older toilets have like 3.5 gallons per flush versus 1.6 gallons per flush. And the design flow per bedroom increases from 110 to 150 gallons a day. As Mark has already stated, the minimum lot size is 40,000 square feet for on-site, or for a lot with an on-site septic and a well. And we allow a minimum of 15,000 square feet for a lot that has an on-site septic but can connect to a public water supply. Before the design of a private septic is completed, as Mark has already stated, we go to the site and do a soil and site appraisal, and we meet the contractor out there to do an analysis of the soil and site different locations of the wells and neighboring wells and the best location for a septic system. Some examples as to what we want to watch out for are, like, if a house is on the lake or near a stream, we want to site a location where the septic system is going to remain above the 10-year flood elevation. And sometimes you just look for high water marks. And you want to maintain the septic system on slopes of less than 15%. And one of the big things that we look for is we do a deep soil test. And Brian's going to go into that a little bit more detail, but you want to maintain the bottom of the septic system at least 4 feet above rock or unsuitable soil or seasonally high groundwater levels. And you always want to maintain a 50% reserve area for future expansion or replacement system. So one of the most important things that we do in the site investigation is we want to site the septic system to maintain minimum separation distances, and there's a table that I'm going to get to, but you want to look at the separation distance to drinking water wells, both your drinking water well and neighboring wells, from buildings, property lines, water bodies, and also other utilities. And this table might be a little difficult to see. I apologize for that. But you might be able to see it a little bit better in your handouts. I know it's kind of small. But an example would be separation distance from your absorption field to a drinking water well. The minimum distance is 100 feet. And it's also got to be 100 feet from a absorption field to a stream or a lake, 20 feet to a dwelling. And if you go up to a septic tank, because it's considered a watertight tank, you can cut that separation distance down from 100 feet down to 50 feet. So you've got room to install it between the house and property lines and that sort of thing. But this is the table that when we're siting a location of a septic system, this is the table that we refer to for that. And here's a diagram that kind of shows the location of a structure and a basic septic tank absorption field system. As you can see, the house well is shown to be 100 feet from the neighbor's on-site wastewater treatment system. And then also the replacement area, because you want to maintain 100 feet distance from the neighbor's well, must also be located in a spot that is not, that is going to maintain that separation distance. Obviously, the most important thing is the location of the septic system and its components is to minimize risks to public health in the environment. So I've already gone over a little bit of this, but the main purpose of the investigation is to cite the location of the septic system. But we also gather data for actually designing the system. So Brian's going to go into that a little bit more detail. But so we want to look at the level of the, elevation of the groundwater level and any impervious soil strata. We do a test called the percolation test, and what that does is determine the actual speed at which water would actually move through the soil structure. And the size of the septic system, the absorption field, for example, is actually based on the design flow that you're trying to design it around, plus the percolation rate that's tested for in the field. And this has already been covered a little bit. I'm just going to briefly go over this. The main purpose of the septic tank is to provide the primary and actually the first stage of treatment in the septic system. Solids settle out, grease floats to the top, and as already been discussed, there's actually filters that we require on new systems that be put in the outlets, and that actually provides a little bit extra treatment too, so it filters out some of the smaller solids that might not settle or might not float to the top. And that is an extra safeguard from keeping the solids from floating out into your absorption system, which can cause problems further down the road with clogging the pipes and the holes in the soils. Different types of septic tanks would include concrete, fiberglass, and polyethylene. Probably the most common type of septic tank is the concrete tank, a precast concrete tank. This has already been discussed too. We require 1,500 gallon tanks for sand filters, but when you get into sizing absorption fields, you look at the number of bedrooms that you're designing it around, and the minimum septic tank is 1,000 gallons. And then here's a table to tell you what the minimum size is. And this is just a minimum size. If you want even further treatment and actually more protection for your absorption field or your sand filter, you can actually increase the size, and that's going to allow more settleability of the solids, and that's going to help protect your system down the road even longer. So from the septic tank, the clear liquid is actually called the septic tank effluent. That flows through a little sewer to different types of distribution devices. The most common is the distribution box, and that distributes the septic tank effluent by gravity to your tile field or your absorption bed or your sand filter. But in some cases, you might need a pump. Like if you need to locate the septic tank uphill from your structure, and you've seen in some of the earlier slides where there's pictures with steep slopes going down the hill, where you got to use a pump to pump it up to those treatment systems. So you'd use a pump rather than a distribution box to get it up there. And other types of dosing devices would include a siphon or a flout, and you can't use those to go up gradient, and you can use those. It's actually a better device to dose a system to the distribution box because the system's going to constantly see the same amount of flow rather than surcharges. And but they're a little bit more on the expensive side versus a distribution box, but you do get a better product down the road. Again, this table is probably a little hard to refer to. I've got some examples to go over, but this is the table that we use to size a conventional absorption trench and beds. And one thing I should mention is that an absorption trench and beds are used in soils where you've got a good percolation rate. Basically, percolation rates that are under 60 minutes per inch are considered acceptable soils to use this type of system, and above a minute per inch. If your perk rate is less than a minute per inch, then then the soils will be too fast, and you could send inadequately treated septic tank effluent into the groundwater. So you want to try to avoid that. So here's a pretty basic example. We've got a 3-bedroom house with a perk rate of 5 minutes per inch. And according to Table 4A that I just referred to, if you got a 2-foot wide trench, the total length of your absorption lines should equal 138 feet minimum for the newer style plumbing fixtures of 110 gallons per day. And if you go down to the oldest style fixtures that's in the table of 150 gallons per day, you would increase the size from 138 feet to 187 feet. So by reducing or by upgrading plumbing fixtures from the older style to the newer style, you can essentially reduce the size of your septic system, which would save money if you have to replace it. So here's an example showing a perk rate of 20 minutes per inch, which is soils that may not be as gravelly, may have a little bit more finer soils in it, like silts, maybe a little, little amount of clay in it, some sands. And as you can see, with 110 gallons per day, it increases from 138 feet to 236 feet of total absorption trench. And you would need 321 feet at 150 gallons per day per bedroom for the older style fixtures. Absorption beds can be used in good perking soils like the trenches, but unfortunately, with the beds, you've got all of your piping on one level. Whereas with the trenches, you've got sidewall areas that also help allow the septic tank effluent to perk into the soils. So with absorption bed, basically you're looking at approximately 70 to 75% larger of a application rate that you're going to be using. So the size of the bed actually would be bigger versus the total size of the absorption field. And as you can see here, a 3-bedroom house with a perk rate of 5 minutes per inch, the minimum absorption bed area is 347 square feet, whereas the total square feet using absorption trenches would be 275 feet. And it's been mentioned earlier, seepage pits. We do not allow seepage pits for new construction. We've just run into too many problems with them. Early failures. Sometimes they get installed in the soils that they shouldn't be. A lot of times they're installed in areas where the groundwater level may be higher than they really should be. And, seepage pits are installed much deeper. We're looking at, 8 feet or, 7 to 8 feet deep versus, 3 feet deep to, 2 feet deep. So you're putting that septic tank effluent much closer to the groundwater with a seepage pit than you are with an absorption field or a trench, or a bed, rather. And this has already been discussed. I'm going to really quickly go over this. I'm not going to go into this in any detail. But the updated 75A includes standards for the new gravelless type of systems and the enhanced treatment units, the ETUs. And 75A says that in order for them to be used in New York State, they must have the NSF certification, National Sanitation Foundation certification. And some of the examples of the gravelless system, some of the products that are out there include Infiltrator, ADS, Presby, Elgin, and a big benefit of using a gravelless system versus an absorption trench is that 75A allows the use of them, but it also gives you a 25% reduction in the total absorption area versus conventional absorption trenches. So you might be spending a little bit more to buy that gravelous type of system like an infiltrator, but you're also given a 25% reduction. So you might, you're going to want to, if you have to replace your system, you want to do a cost analysis to see which one would actually be cheaper, because 25% reduction may actually reduce it down to an affordable amount. And some of the ETU examples that have already been discussed includes the peat moss system or a fixed film media like he's shown. Aeration units are also an example. We've got a lot of aeration units around the lake. They were put in back in the 80s. In order to use these, you got to have a maintenance agreement with the supplier, according to 75A. But one of the benefits of using an ETU is that the subsurface treatment system that follows an ETU qualifies for up to a 33% reduction in the total absorption area. So, if you're looking at replacing a system along the lake, the ETU provides the extra treatment, but in order to stay within a smaller lot, you can use a 33% reduction to your advantage for siting the absorption field, which is important if you're trying to maintain a separation distance to, from wells and property lines and that sort of thing. So I've gone over some of the systems that are used for good perking soils, but another common type of system that we've got in our county, most of you may know about them, are the sand filters, and they're used on sites where the perk rate is either too fast, like I had mentioned, which would be a perk rate of less than a minute per inch, or too slow, perk rate of greater than 60 minutes per inch. Perk rate too fast includes very coarse sandy and gravelly soils. We've got some areas around the lake that actually have extremely fast perk. Finley Lake, for example, almost the entire area surrounding Finley Lake is very, very coarse sandy gravel. And, some of the soils there, or some of the areas around Finley Lake also have higher groundwater levels because as you're getting closer to the lake. So that really decreases the time that it takes for that septic tank effluent to get into the groundwater, and it decreases the distance between the septic system, the bottom of the septic system, and the groundwater. So the very fast perking soils and very slow perking soils, you want to put in a sand filter. And sand filters provide an extra level of treatment versus the absorption fields too, because they actually help filter out some of the pathogenic microbes that might be in, or that are in the wastewater. So you're filtering out the pathogens, plus you're slowing down the perk rate. So if you're trying to get that extra level of treatment of the septic tank effluent, sand filter is a good route to take. And in 75A, gravity dosing is allowed of the smaller sand filters. Actually, 900 square feet is actually a very large residential size sand filter, but I also work with a lot of commercial size sand filters that are much larger than 900 square feet. And in the larger sand filters, they must be dosed with a pressure or with a pumping system and be pressure dosed. And as I mentioned earlier, the siphons and the flouts are actually a preferred method to dose any type of septic system. Because you are evenly dosing the system rather than hydraulically, possibly hydraulically overloading the septic system like was mentioned earlier when you're doing 7 loads of laundry on a weekend. There's a little bit of a storage in the chamber that actually holds the siphon or flout, so you've got a little bit of time there to actually fill that chamber up so you can dose your absorption field or sand filter over time.
Today I'm just going to present kind of how it hits the ground floor, I guess. I'm the guy out in the field trying to explain to you all those charts and offsets and distances and why you can't put it where your old one was. So we talk a lot about new construction versus correction. Site evaluation is a big part of my job to make sure that we deal with some of the problems prior to them becoming major problems. The different design options you've obviously been privy to here 2 or 3 times. But biggest thing, I guess I'm going to go over some of the application process and what we do to ensure that those offsets and construction things are met. So like we said, new construction, there's no wiggle room anymore unless you get the Board of Health to okay your PE design, but we have to be very strict with the offsets and distance to ground or to your wells. So that's what I go out on a site to make sure that you're going to locate your house in an area that we still have room to locate your septic system. It's happened before. But with corrections, the house is there. We do the best we can. There are well variance sheets so we can inform you that you haven't met New York State criteria for offset, but we still try to design the system to keep as far away from the water wells as we possibly can. So on a site evaluation, I meet typically either the landowner or landowner and contractor on the site. So irregardless if it's a new construction or correction, all this stuff still has to be looked at. So the number of bedrooms in the home, obviously Paul was talking about gallons per day per bedroom allowable. The number of bedrooms are important, and that does include multiple offices. I always get that. I got 2 bedrooms and 4 offices. Garbage disposals, as you've heard about, we usually add a bedroom size to that. Soil type, you know, the percolation rate, depth of groundwater, that's a biggie. Again, offsets. We have to look for wetlands.